You are very much welcome to my channel today. Today we'll be looking at Venn diagram. And Venn diagram is simply the diagram we use to represent sets. And we have the rectangular box for the universal set, and then we have circles for the subset of the universal set. So here is my first example where I have a Venn diagram, the rectangular box for the universal set. You can see my universal set. Okay, then I have set A and set B. Okay, I can have 1, 2, 3, 4, 5, 6 here. Then I have my alpha, my beta, and then my gamma. Okay, now I can as well have, let's say I have P, Q here. Okay, for set A, everything in this shaded portion is in set A. So my set A contains these elements: 1, 2, 3, 4, 5, and 6. Okay, so that is it. So everything in this shaded portion is in A. So that is why I say that the shaded portion represents set A. Okay, so that is it. So move over to my second set. Okay, my second Venn diagram. My second Venn diagram. I still have my rectangular box, and that is for union of sets. Now, if I'm to take the union of the set, it's going to be everything in here. Everything in A and in B. So I'm shading the union now. Everything in A and in B. That is the union. Everything in A and in B. Okay. So that's it. Everything in A and in B. So that's the union. This shaded now. This place that I have shaded now is the union. So you take every element in A and B, then you don't repeat. Okay, no repetition is allowed. Okay, so that is A union B. Everything in A and in B. So that's union of sets. Okay, alright. So we'll go to the next Venn diagram. We talk about intersection of sets. So what they have in common. So here is the intersection, this place now. This E, is E intersection F. So this is E intersection F here. Okay, so this is E intersection F. What they have in common. What do they have in common? So that's what we are looking at. Okay, so what they have in common is in the space. What they have in common is in that space. E intersection F. Okay, so whatsoever that is in this space is what they have in common. Okay, so that is it. Now we talk about A complement. A complement is simply what is in the universal set that is not in A. Let me use this. It's the same way of representing it. That's what is in the universal set that is not in A. So what it tells is everything outside A. Everything outside A. Everything outside A is in the A complement. Everything outside A. Okay? Everything outside A is in A complement. Every element outside A is in A complement. That is the elements that are not in A. They are the A complements. Okay, so that's it. So we look at subsets. Subset is a set that contains all the elements in another set. So it's like a set in another set. So this B here is in A. So B now is a subset of A. B is a subset of A because every element in B is in A. Okay, so that is it. So let's look at this example whereby our universal set is an integer and it ranges from 1 less than or equal to x strictly less than 15. And then we have E, even numbers, and then we have F, factors of 12. So let's list out the sets, the elements. So start with the universal set. So we have 1 is there, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. 15 is not there because it's strictly less than 15. Then for E, we go for even numbers here. We have 2, 4, 6, 8, 10, 12, 14. These are the even numbers. Then for F, we look at for factors of 12, 1, 2, 3, 4, 6, 12. These are factors of 12. So for the Venn diagram, which I will put down here, so we have the rectangular box. Okay, enough. So have the rectangular box. That's for the universal set. Then I have my circle. So this is for E and this is for F. Okay, let's start with what they have in common. I have here I have 2, here I have 2, so 2 is common. Here I have 4, 4 is common. Here is 6 is common. Here is 12 is common. So that is it. So for F, I have just 1 and 3 remaining. Then for E, I have 8, 10, and 14 remaining. But we still have those in universal set that are not yet in this EF. So I have my 5, I have my 7, I have my 9, I have my 11, and I have my 13 this side. Okay, so that's our Venn diagram. So let's fill in members of E intersection F prime. So first we reach out for our F prime. So remember I said there are elements in the universal set that are not in F. So let me close up F. This is my F. So if I close it up, so what do I have remaining? These ones. So that will give me 5, 7, 9, 11, 8, 10, 14, and 13. So these are F complements. So now I can tell what the E intersection F prime is. So what is in E that is also in F prime? So let's see 8, 8, or you can just see it here. 10, 10, 14, 14. So we have 8, 10, 14. So the number of values we have in E intersection F prime, the value will be the number of elements. That is 1, 2, 3. So 3 of them. So that is it. So first you list out the elements, then start with the common ones and fill up your circles, then the remaining will be in the universal set. And then if there are questions later, you can now fetch them out from the Venn diagram. Alright, so that is it for today. Thanks for listening, and if you have any questions, just drop it there in the comment section below. Thank you and God bless you. Bye bye.